Welcome to Science Hub. Today, we're diving into the fascinating world of black holes and uncovering a cosmic event that challenges our current understanding of these mysterious entities. In November 2023, astronomers detected gravitational waves emanating from a spectacular collision between two massive black holes. These waves, captured by ground-based detectors like LIGO, Virgo, and KAGRA, traveled a staggering 7 billion light-years to reach us. What caught scientists' attention was not just the collision itself, but the sheer size and rotation of the black holes involved. Each had a mass ranging from 100 to 140 times that of our Sun and spun at nearly the speed of light. According to existing theories, black holes of this size should not form from collapsing stars followed by supernova explosions. To unravel this mystery, researchers at the Flatiron Institute's Center for Computational Astrophysics conducted intricate simulations, incorporating a factor often overlooked: magnetic fields. These simulations revealed that magnetic fields are crucial in shaping the star's evolution after it collapses. Instead of the black hole absorbing all the remnants of the exploded star, magnetic fields expel a significant portion of the material, reducing the final mass of the resulting black hole. One of the puzzles that perplexed scientists was how black holes could exist within a mass range previously deemed impossible. Typically, stars collapsing into such massive black holes undergo a colossal explosion that leaves nothing behind. However, the new simulation suggests that magnetic fields create a spinning cloud of material around the nascent black hole. This cloud feeds the black hole, increasing its rotational speed while lowering its ultimate mass. These findings point to the potential for testing these hypotheses by observing gamma-ray bursts associated with the formation of such black holes. Detecting these bursts would provide compelling evidence of the role magnetic fields play in forming rapidly spinning black holes. This research marks a significant step toward a deeper understanding of black holes and their evolution. By emphasizing the role of magnetic fields and conducting precise simulations, scientists have offered an explanation for an event once considered impossible. These discoveries pave the way for further exploration into how magnetic fields influence other cosmic phenomena. If you enjoyed this deep dive into the mysteries of black holes, make sure to subscribe to Science Hub for more captivating science content.